All right, let's dive in. Today, we're all going to be data detectives. Our mission, should you choose to accept it, is to see if we can actually predict the future by looking at the past. And our secret weapon is a tool called R. We're going to use it to uncover hidden patterns in data and basically become future forecasters.
It's the ultimate question, right? How do we know what's coming next? Do you need a crystal ball, some kind of time machine? Well, it turns out the answer is usually a lot simpler. The clues are almost always hiding in plain sight, in the data.
And that's really the big secret here. Forecasting isn't magic. It's the art and science of finding the story buried in the numbers. It's about listening to what the past is trying to tell us about the future.
So, just like any good detective, the very first thing we do is survey the scene. For us, that means just plotting our data. Let's just look at it and see what story immediately jumps out.
Okay, so the first clue we're always looking for is something called a trend. A trend is just the long-term direction of the data. Is it generally moving up or is it heading down? And believe it or not, one of the best examples comes from, well, fashion history. Just look at this graph. Back in 1866, the diameter of women's skirts was about 600 units. But then, for the next 15 years or so, it just kept going up and up and up, peaking at over 1,000. Then the trend completely reverses and it falls all the way back down. That clear rise and fall over decades, that, right there, is a trend. Now, the second big pattern we look for is something we call seasonality. And listen, this doesn't just mean winter, spring, summer, and fall. In data, seasonality is any predictable cycle that repeats itself over a fixed amount of time. Take a look at this data on births in New York City. You see that pattern? It's impossible to miss, right? Every single year, like clockwork, there's a big spike in births in the summer and a dip in the winter. And what's really important is that the size of that wave, the peaks and troughs, stays pretty much the same year after year. That's a perfect, classic seasonal pattern.
Okay, so we've spotted a trend and we've spotted a seasonal pattern. But how do we pull them apart to really understand what's driving the data? Well, for that, our detective work requires a cool technique called decomposition. You can think of any time series as being made of three fundamental pieces. First, you've got the long-term trend. Second, you've got that repeating seasonal cycle. And third, you have everything else that's left over, which we just call random, unpredictable noise. And this is where a tool like R is just incredible. It can take that messy, complicated birth data and instantly break it down for us. Look at this. We can now clearly see the underlying trend, that little dip, and then a steady rise. And we can see the pure seasonal effect, isolated from everything else, that consistent peak in July and valley in February. This is that aha moment where the confusing mess of data suddenly tells a very clear story.
All right, this is where it all pays off. We've found the patterns, we've measured them, now we can finally use that information to predict the future.
And here's the key. The patterns we just found tell us exactly which forecasting tool to grab from our toolbox. It's actually pretty simple. If your data is kind of flat, no real trend, no seasons, you use a simple tool. If you see a clear trend but no seasons, you grab a different tool called Holtz. But if your data has both a trend and a seasonal pattern, you bring out the big gun, the Holt-Winters method. So let's try it out on a real-world example. This is monthly sales data for a souvenir shop in Australia. And just by looking at it, you can spot two things right away. One, sales are generally trending up over the years. And two, there is a massive spike every single year. This is a textbook case for our Holt-Winters model.
And boom, here's the payoff. On the left, we've got the past. On the right, we've got the future, predicted by our model. You can see how the Holt-Winters model literally learned that upward trend and that yearly sales spike. And then it just extended that pattern forward. We now have a solid data-driven forecast for the next 4 years. Pretty cool, huh?
Now, these smoothing models are fantastic. They're a core part of our detective kit. But sometimes, the patterns are trickier. The clues are more subtle. For those really tough cases, we need to bring out the heavy artillery. Okay, don't let that name scare you. It's actually not that bad. Autoregressive just means the model assumes that what happened yesterday influences what happens today. Simple enough. Moving average means the model looks at its own past mistakes to get better. It's literally learning as it goes. By putting those ideas together, ARIMA models can find really complex relationships that other models might just miss entirely.
So, we have just sped through a ton of information. Let's take a quick step back and put all the pieces of our data detective workflow together. What have we really learned? When you boil it all down, it's this incredibly powerful three-step process. Step 1, you look. Just plot the data and see what's there. Step 2, you analyze. You break it down into its core parts, the trend, the seasonality, and the noise. And Step 3, you predict. You pick the right tool for the job and forecast what's coming next.
And that's the whole point. This isn't about wild guesses or just hoping for the best. It's about having a system, a repeatable, logical process. Tools like R give us a way to turn a boring list of numbers from the past into a really meaningful, defensible forecast for the future.
And that really brings us to the most important question. This workflow we just walked through, it can be applied to almost anything that happens over time. So now that you know how to look for these hidden patterns, what stories are waiting to be discovered in the data all around you? What future will you try to forecast? Thanks for joining us.